This is one of the problems that we worked through the other day, and I've gone through the steps where we've broken down 75 as the perfect squared number 25 times 3. We've broken down 27 as perfect squared number 9 times 3, simplified each part, combined like terms, and we have then subtracted what is outside those radicals. Now we're going to look at this one on the calculator just to make sure that we understand that it can be done. So we're going to type in the original problem. It was the square root of 75 x to the third power. We have to make sure that we click outside of that since the other term is a separate radical, and it is minus the square root of 27 x to the third power. And you can see it gives a graph, and the reason for this is because it contains that variable x. So we're going to type in the answer, and I'm just going to type in the correct answer, which was 2x times the square root of 3x. And as you can see, the graphs match up perfectly. I have the red graph, the original problem. I have the blue graph, and the only thing we see is the blue graph, which means that it is directly on top of the original problem. Right, on this problem, we are simplifying a radical that contains a fraction. And when we do that, it's best to go ahead and simplify inside first. So what I did is I looked at the problem and said, I know that 9 and 24 are both divisible by 3. So I simplified the fraction 9 over 24 to be 3 over 8. I simplified my variables. When we have variables on top and bottom, we have to remember from Algebra 1 that you look for the largest degree of the exponent. That tells you where it's going to go. Since this is x to the 5th power, I know my x is going to be on top, and to get the degree, I subtract. Once I have that fraction simplified, I'm now going to break it apart. The square root of the numerator divided by the square root of the denominator. And then I'm going to do what is called rationalizing the denominator. And what this means is that I have to make the bottom, the denominator, a perfect squared number. And I've listed below here my perfect squared numbers. My perfect squared numbers are 4, 16, 25, 36. I can't make 8 4 by multiplying. But my second number is 16. I can multiply 8 by something to get 16. So I would then multiply by the square root of 2, top and bottom. That's going to give me the square root of 6x squared on top. On the bottom, we have the square root of 16. And on my final answer, I'm going to have the square root of 6x squared over 4. All right, just reviewing over the terminology, we have 3 terms that are dealing with radicals. The first of those is the radical symbol, okay, and this is this symbol. The second term is the radicand, and the radicand is what is inside the radical. And the third term is index. And the index in this particular case is a 3, which is indicating that we are doing the cube root. Okay, if there is no index, we know that it is invisible and it is understood to be 2. So if I just see this, I understand that is the square root. All right, let's look at a couple of problems. We're simplifying radicals that have indexes greater than 3. And what we're going to do is we can look at this number 54 and say, okay, 2 goes into 54. How many times does 2 go? It goes 27. Well, look what happens. 27 is a perfect cube number. So just by understanding that because this is an even number, I can divide it by 2, I can automatically get that perfect cube number in this example. So I'm going to write this as the cube root of 27 times the cube root of 2. Simplify the cube root of 27 by typing that into Desmos, and that is going to be equal to plane 3 times the cube root of 2. What we have to be sure that we don't do, okay, and a lot of times we will forget this, we'll write our answer like this. And this is not the same thing. This is actually the square root. So if you are going to have a cube root problem, you need to make sure that you do have that index in your answer. All right, the division is basically, if you're doing the cube root of a variable, it's the same way as we did with the square root of a variable. You're going to take the index, divide it into the exponent. So I have 3 divided into 5 one time. Subtract, and I get a remainder of 2. Therefore, that tells me that my quotient, which is the number of times that it goes into the 5, tells me the exponent of the variable outside. So that means I'm going to have x to the first power outside. And inside tells me that I'm going to have x squared. What I like to do is pretend that this is the radical, that r represents radical. And this tells me that I'm going to have x to the first inside or outside, and this tells me I'm going to have x to the second inside. All right, we're going to be looking at rational or exponents, and rational exponents are exponents that are written as fractions. Very, very simple process. What we have to understand is if you have an expression, and let's say that we have the square root of x to the third power. If I'm writing this in as a rational exponent, as a fractional exponent, what I do is I drop the radical sign, so I just have the x. The exponent is going to always be the numerator of my fraction, and the index is going to be the denominator. So the square root of x cubed is the same thing as x to the 3/2 power. A couple of problems that have been shown convert between radical and exponent form. This one is in radical form. The inside part, the radicand, does not have an exponent, so I need to put this 1 there because when I write it as a fractional exponent, the numerator comes from the power of that variable or number inside. So I drop the radical. My numerator is 1. My denominator is 1/4. Y to the 2/7 is written as a fraction. When I have y to the 2/7, I know that my denominator is always going to be the index. So when I write this as a radical, my index is going to be 7, and my numerator is always going to be the exponent inside. All right, so whatever's on the bottom is going to be your index, and the exponent is going to be the numerator of that fraction. All right, this question asks for the index of the fourth root of 3 squared, and I've gone ahead and indicated the terms again. The 3 squared inside is your radicand. The symbol itself is the radical, and the index is the root. Okay, so in this particular case, our index would be 4. All right, the first problem is the cube root of 405. I've listed some cube numbers. This is 2 cubed. We have 3 cubed, 4 cubed, 5 cubed, and so on. This one would be 6 cubed. And what I can do is take the number 405 and divide it by these factors. When I do that on Desmos, if I divide 405 by 8, I get a decimal, so I know that can't be a factor. I divide 405 by 27, it is equal to 15, and that tells me that I'm going to use those as my 2 factors. So I break this down as the cube root of 27 times the cube root of 15. The cube root of 27, when I type into Desmos, is plain 3, and the cube root of 15 cannot be broken down. All right, fourth root of 81. I would advise on any problems that the exponents are larger than a square root, always type them into Desmos and see what happens. When you type in the fourth root of 81, it tells me the answer is 3. That's because when I list my numbers to the fourth power, 2 to the fourth power is 16, 3 to the fourth power is 81. So 81 is a number that is raised to the fourth power. On example 3, we have the fourth root of x to the 25th power. Just like in square roots, we're going to do division. We're going to divide the index into the exponent. 4 will go into 25 6 times. 6 times 4 is 24. I subtract to get a remainder of 1. That means I'm going to have x to the 6th power outside. I have x to the 1st power inside, and make sure to put that fourth root. On number 4, it didn't have an index. Therefore, we know it is 2. So that means I'm going to be dividing 2 into 27. 2 will go into 27 13 times with a remainder of 1. And when I write my answer, I'm going to have x to the 13th power in front of the radical. I'm going to have x to the 1st power inside. Right, on this particular problem, if you were doing this on an SOL test, this is actually a drag and drop, but we're just going to go ahead and work it out. Cube numbers that I'm looking at, we have the numbers 8, 27, 64. I could go on to 5 cubed, which would be 125, 6 cubed, 216. So 162 is not a perfect cube number. So I would do 162 divided by 8, and that would give me a decimal. I would do 162 divided by 27, and that's equal to 6. So 27 and 6 are going to be how I break down the cube root of 162. I get the cube root of 27 times the cube root of 6. Then simplify this to be 3 times the cube root of 6. So I'm going to put my 3 outside, my 6 inside. I divide on my exponents. On my x's, I divide 3 into 6. I get 2 remainder 0. So that tells me I have 2 x's outside, no x's inside. I divide on the y's. 3 will go into 7 2 times with a remainder of 1, which tells me that I'm going to have y squared outside and y to the 1st inside. All right, on this one, we're going to talk about what to do if we're multiplying 2 cube roots together. First thing you want to do is you want to multiply first. Okay, that means that you're going to take the 2 and you're going to multiply what's inside together and put it under 1 cube root. So we have the cube root, 6 times 4 is 24. W to the 7th times W to the 5th. I have to remember that I'm adding those degrees to get W to the 12th power. I break down the cube root of 24 as the cube root of 8 times the cube root of 3. And when I simplify that, that becomes 2 times the cube root of 3. I now do my variable by doing the division. 3 will go into 12 4 times. I have a remainder of 0, which tells me that I'm going to have w to the 4th power outside the radical, in front of the radical, and I have no w's inside. All right, on this one, we're practicing again, either changing from radical form to fractional exponent form, or vice versa, fractional to radical. Remember that the denominator is always going to be your index. So when I write this, this is going to be the 5th root of 2 squared, and I could write that as the 5th root of 4. On the second one, it is in radical form. Therefore, I'm going to write it in fractional exponent form. I take my exponent inside, which is 5 squared, and I divide it by the index, which is 4. Now, we have to make sure that when we're dealing with fractions, that fractions are always simplified. So what I have to do here is simplify this to be 5 to the 1/2 power. On this third one, it's in fractional form. Remember, my index is the denominator, so this is going to be the cube root of x to the 1st power, or cube root of x. We normally would not see that exponent of 1. Number 4 is the square root of x to the 5th. We understand that that index is 2 because it's invisible. It's understood to be 2. And I'm going to write it as a fraction by taking what's inside, x to the 5th power, and putting it over the index 2. All right, if you have a number given to a power, you can automatically type this into Desmos and just figure out the answer. But we could do this problem also by converting it back into radical form. The index is going to be 3, so this is going to become the cube root of 8 to the 4th power, and I can do the cube root of 8, which is 2, and raise 2 to the 4th power to give me 16. But if you have a problem that is just a number raised to a fractional exponent, type it into Desmos. Right, on this one it says which expression is equivalent, and if we look at the answers, we see that the answers are in fractional exponent form. So that lets me know that I'm going to convert this from radical form to fractional exponents. Everything inside needs to have an exponent. That's why I've gone ahead and put a 1 on this 16. It was understood to be 16 to the 1st power. So that when I convert this, and I know that I'm taking each of those fractions or each of those exponents and dividing by the index, I have to make sure that I do have an exponent in that position. So this would be 16 to the 1/4 power, x to the 15/4, y to the 17/4. 16 to the 1/4 power simplifies to be 2. We should always type the number part in the calculator, and my final answer would be 2, x to the 15/4 power, y to the 17/4 power.